with a minimum. It's just that the sign is different. So let's talk about the sign for a minimum. The derivative must be negative first, 0 or undefined, and then positive for that point to be a minimum. Derivative negative, positive or 0 or undefined, and then positive. So same for local min. F prime being 0 plus, I shouldn't put plus because I don't want it to confuse you, and changes sign negative to positive, or F prime undefined and where the function is defined. So it has to be a critical number. So all these must be critical numbers, right? So x is a critical number. Otherwise, if it's not a critical number, we cannot talk about max min. So I'll put in parentheses, x is a critical number. And changes sign negative to positive. Okay, keeping this in mind, let's take a look at study the max min of a function on a closed interval. So let's look at another type of function so we see all different types possible. T the square root of 4 minus t squared, and this is on the interval -1, 2. I strongly recommend start getting used to the table that I'm going to use because it's extremely helpful. I do not take credit for it. It's not my own. I would not take credit for it. Okay, so t, these are the values of the variable, only between -1 and 2. Then we're going to look at f prime of t, and then the next row will be f of t. First of all, I need to know whether this function has critical numbers. I don't know if it has critical numbers or not till I find the derivative. So f prime of t, this is a product. I have to be careful. The first function prime is 1, the square root of 4 minus t squared plus t times the second function prime, which is 1 over 2, the square root of 4 minus t squared times the inner function prime, which is -2t. Do we agree with this?
Yes.
Any questions? So the first function prime was 1 times the second one plus the first function times the square root prime, 1 over 2 the square root times the inner function prime. Yes, I will simplify the 2 with a 2. I will find the least common denominator, but let me rewrite it first. So the square root of 4 minus t squared, careful there is a minus here, minus t squared over the square root of 4 minus t squared. And there is only one denominator, so obviously it's very clear, but this needs to be multiplied by it because its initial denominator was 1. So when I multiply them, I get a very nice answer, and then minus t squared. Okay, I combine like terms. I get -2t squared plus 4, and over the square root of 4 minus t squared. You know me already. I will factor out -2, and I get t squared minus 2 over the square root of 4 minus t squared. If you do this at all times, and if you get into the habit of doing this, you will always make everything as simple as possible. Good. So I see that this is undefined, so there are two possible sources for critical numbers. I see it's undefined. I don't have to contradict that, because 4 minus t squared has to be greater than or equal to 0 in the function for the function to exist. So, but definitely now this radical is in the denominator, so I cannot include, so 4 minus t squared cannot equal 0, or t squared cannot equal 4, or t cannot equal plus or minus 2. So I already found one critical number. You can say, how come? Right here. This function is undefined. To show undefined in my table, I put a bar. I don't have a number underneath. I cannot put a number underneath. It's undefined. How come that I don't choose negative 2? Simply because negative 2 is not in the domain that was given to us, in the interval that was given to us. So there is no point in discussing negative 2. So I will say only t equals 2, critical number. From this source, when the fraction or the derivative is undefined. But I also have another possibility. When the derivative is 0, so the second source is when f prime of t is 0. A fraction is 0 when the numerator is 0. Or t squared equals 2, and of course I will take the square root, plus or minus the square root of 2. These are critical numbers, if they both fit in our interval. One of them does, which is 1.41, and I'm going to go back here and put it in, the square root of 2. But the other one is negative 1.41, which is to the side of this, so I'm going to say only t equals the square root of 2. So the function has two critical numbers. One is the square root of 2, and the other one is 2. Our next step is study the sign of f prime of t. Okay? I go back to f prime of t, and I notice that this is a square root, which is always positive. I also notice that 2 will not affect the sign. So the sign will be given only by negative t squared plus 2. Negative t squared plus 2. Okay. So I know that between negative 1 and the square root of 2 I have 0. I'm going to plug in 0. 0 here, negative 2 times negative 1 is positive. Here, this is 1.41 and this is 2. I cannot plug in 2. Well, actually I can, but I should plug in 1.9. So again, this is all positive. I'm not going to waste my time thinking about it. I'm only going to plug in what I see. So 1.9 squared will be more than this. That's all I care about, sign. 1.9 squared is definitely, it's almost 4. It's definitely more than 2. So this will be positive, but there is a minus in front. So then I know this is negative. Good. Now, I will plug in the function, this value, and this value. Always the endpoints and the extra critical numbers. Here's my calculator. I will plug in the function in y equals. Bear with me, I just purchased this calculator because the other one is dead. I spilled water, as I mentioned. Sorry about that. So x, the square root in parentheses, that's me. Depending on your calculators, you may have to put them in, and close the parenthesis. And now I'll go to second table. It's not set up yet, so I have to go back to table set. Okay, second table, and plug in -1, the square root of 2, and 2. -1, the square root of 2, and 2. So here's what I got. -1.732. For this I got 2, and for this I got 0. Of course, most probably I didn't even have to use a calculator, but we did. At this point, I asked myself, do these two rows work well together? This is the moment in which I say, wait a minute, I have an error somewhere. I have to go back to the drawing board. Something is fishy. If these two do not work in sync, I'll say oops and go back from scratch. So from -1.732 to 2, what does the function do? Between -1.732 and 2, what does the function do? Up or down?
Goes up.
Good. Is that supported by the sign of the first derivative?
Yes.
Yes. Excellent. Well done. Then I look again. What does this function do between 2 and 0?
It goes back down.
Is that supported by the sign that I found for the first derivative?
Yes.
It is. So my two rows work in sync. Can I still have an error somewhere? It's all possible, but doubtful. I'm doubtful. Okay, so now I have to make a decision. So I'm not graphing the function, but I see these three values, something like this: -1.7, up to 2, down to 0. -1.7, up to 2, down to 0. So let's start with this one. So what type of point is 2, the square root of 2 comma 2? Which is this point?
A relative max.
It is a relative max. And what else? Also
A critical point. Number.
yes, an absolute max. There is no other value on this interval. The function starts at the y value of -1.7, it reaches 2 somehow, and then it drops down to 0. So there is no other value higher than it, guaranteed. Because if it were, we would have found a critical number there. But we only found a critical number at 2. At the square root of 2 when y is 2. So this point being the highest, it has to be a relative max because the function exists on both sides, and it is also an absolute max. What about this point, which is -1 comma -1.7? What is this point? It cannot be a relative min because it's at the end point of the interval. But because it's an absolute. Because there is no other point lower than it on the given interval. So this is an absolute minimum on this interval. What can I say about the point 2 comma 0? This is the point 2 comma 0. What can I say about 2 comma 0? Is it a local max or min?
Min.
It cannot be at the end point of the interval. It cannot be a local max, local min. What about absolute max, absolute min? No, because there is a value that is higher than it, and there is a value that is lower than it. So I will say this is nothing. It's nothing. It has no specific importance. It's not the highest, it's not the lowest. It's not in the interval, so it cannot be a local. And it cannot be a global or an absolute. This is how we study a function on on a given interval. Would we like to look at another, or we continue?
Can we do another one?
Yes. Okay, let's look at an exponential this time because we haven't gotten to that. We still have to look at a trig. We should look at a trig as well. It's a lot of work with those trigs, trig functions. F of x equals x, e to negative x squared over 8. I think I chose this problem on a particular test 3 some semesters ago. Okay. Same questions, everything the same. I would get my table going where I have x, f prime, and f of x. This is fixed. It has to be -1 to 4, no questions. And now I have to find the derivative. I have to find critical numbers and see if they are here. If they're not here and they're outside, I cannot put them inside the interval. They have to be between -1 and 4 if they exist. Okay, so then, I think I'm on 10. Okay, so f prime. Very careful with this function. The first function prime is 1, e to negative x squared over 8 plus the first times e to negative x squared over 8 times the inner function prime, which is negative 2x over 8. I can wait if you need a second to look at this function, and I'll go grab my...
Are you recording this one too? Because I'll be going back and watching the video.
I haven't missed anything today yet, but anything is possible, but thank you for keeping me on track.
Don't say yet. You got this.
Sometimes I do.
The concern with that is there's no icon that says it's recording in the upper corner.
No, because I'm recording on a different device. The problem is that
Okay.
that's why I have 3. The problem is that Zoom will not allow me to record, and I don't want to record you. I don't have any reason to record you. It doesn't allow me to record with the camera that you see what I'm doing with. Okay. Any questions so far? Is this okay? We agree with this?
Yes.
Okay. Of course, you know I have to factor out e to negative x squared over 8. And then I have a 1. And then I'll simplify, and I'll have negative x squared over 4. See how important the factoring and the simplification of this function is? Crucial. I will not know what to do, how to continue. I don't know what to do with all this if I don't factor, and look how nice this cleans up, actually. Because you have an x, you have a negative, and you have another x, so it's negative x squared over 4. I have to find the least common denominator. So this is 4 minus x squared over 4. Of course I'm going to factor on -1. I'm going to bring this to the denominator because it's negative power. And in that case, you don't make a mistake of thinking that it could be 0, who knows what. Anything can happen in a testing situation, right? So now there are 2 possibilities for critical numbers from f prime being 0. Yes, it's 0 if the top is 0, which gives us plus or minus 2. So these are critical numbers, and you can say, wait a minute. No. Only x equals 2. And the other option is when f prime being is undefined. No. This is 4 and this is always positive. Here's the graph of e to the x. It could never be 0. E to any power you want. it could never be 0. So the only critical number that we found is 2. Nothing else. Okay, my next step is I have to study the sign. So I see 0 here. So I will look at 0 minus 4. Again, this is always positive. I will not even waste my time to look at it. So when I plug in 0 on this side from negative 1 to 2, I get positive 4. And on this side, I'm going to plug in 3. 3 squared is 9, minus 4 is 5 with minus in front. At this point, I have to find these 3 values. I grab my calculator. I don't know, it's still charging, I guess. In y equals, okay, do not show this message again, please. Okay, in y equals, I have x. You can put x over if that's what you want, or x times. I will put x over. E. And I will put in parentheses. You know me already. It's possible that some calculators don't need parentheses, but once you get used to a certain thing, it's kind of difficult to change. So second and table. And I have to plug in negative 1, 2, and 4. Negative 1, 2, and 4. And what I got was, or is, negative 0.882, 1.2131, and 0.5413. Okay. Okay, moment of truth. So from negative 0.882 to 1.21, what does the function do?
Increase.
Is that supported by the sign of the first derivative? That's how I catch my mistakes. If the function is increasing and this is negative, I'll say, uh-oh, wow, go back, wrong. From 1.21 to 0.54 is decreasing, and that's supported by the sign of the first derivative. And now I have to make a decision. And it's the same idea. It happened that it's identical. So from negative 0.882, positive 121 to 0.54. So this is the absolute minimum, this is the local and absolute max, and this is nothing. So negative 1, negative 0.882. So this is absolute min, not local min, it's at the end point of the interval. 2 comma 1.2131 is absolute and local max, and 4 comma 0.5413, nothing. Did we get the idea on how to study a function on a closed interval? Finding absolute max, absolute min.
So I have kind of like a dumb question.
That's okay.
Will the last interval, will the last point always be nothing, or?
Oh no, it was just by accident, by total accident. That's what I said, it just happened that it's the same pattern. We can look at another one. No, absolutely not. Okay, let's look at another. Because I don't want you to get that idea.